And in the red for loop, rather than typing out the full gory name of the iterator that is a member of the deck of care class, we just used auto. Now, for the list LC2, since we don't plan to change anything in the list, what we really should ask for is a const iterator. This is the equivalent for iterators of a pointer to const, if, say, you're using a pointer to const to step through elements of an array that you plan not to change. Okay, so IT here is a const iterator that is a member of the list of care class. Therefore, we can access the thing that the iterator is pointing to with $it, as usual, but we could not modify the thing that IT is pointing to by saying something like $it gets capital X. That would be a compile time error. Now, of course, we would really prefer not to have to type out that full obnoxious name, const iterator that is a member of the list of care class. We'd really rather just be able to use auto. But the problem here is that begin returns an iterator that is not a const iterator. So what we do here, because we do want a const iterator, is to use cBegin and cEnd. Okay? cBegin and cEnd yield const iterators, and so now we can use auto to say I want IT to be initialized with lc2.cBegin, that is a const iterator that is, quote, pointing to, unquote, the initial element of this list. And then we go up to, but not including, the const iterator lc2.cEnd. Okay, now since lc2 was initialized using reverse iterators, remember we did rbegin through rend for initializing lc2, what's displayed from the first for loop on slide 49 is hello exclamation mark in reverse, and similarly in the red for loop we display the same thing. Now recall that we initialized the vector of care v8 with the 6 chars HELLO exclamation mark. v8.begin is going to give me an iterator for the initial element in v8, and I can say star of that iterator to give me access to that char that v8.begin, quote, points to, unquote, and I can assign a different char in place of that char element. Now, if I attempted to do this with cBegin, this would fail, because cBegin gives me back a const iterator, and I cannot modify what a const iterator is, quote, pointing to, unquote. Here on slide 50, we have a couple of for loops using reverse iterators to step through the elements of a couple of containers in reverse order. So we're initializing our iterator IT with lc2.rbegin. That's going to be a, quote, pointer to, unquote, the little h that is at the end of lc2. And lc2.rend is going to be just prior to the exclamation mark at the beginning of lc2. So using reverse iterators, I can step through the elements in the list in reverse and display them, and what I get shouldn't be very surprising. It's the reverse of what I got when I displayed lc2 in forward order. Now, a tricky thing to understand here is that reverse iterators still make use of ++ to move to the next item in the list, but in this case the next item in the list is actually the previous item in the list. Alright, so this can be quite confusing, but remember that when you use reverse iterators, you still use plus plus to go from one element to the next element. It's just that that next element is prior to the current element instead of after the current element. Similarly here in this red for loop, we're looking at the vector of care, v8, and we're starting from its r_begin, which is the index of the exclamation mark at the end of v8, and we're stepping that iterator through until we get to the r_end, which is just prior to the little j that is now the first care in the vector. And as I mentioned with LC2, we need to remember to use plus plus on our iterator to go from element to element, this time in reverse. So what we get when we display v8 in reverse is Jello exclamation mark in reverse order, so exclamation mark OLLEJ. Okay, so with these little examples, we've taken a look at iterators, we've taken a look at reverse iterators, we've taken a look at const iterators, and there are also reverse const iterators. So we can select the iterator that we want depending on whether we're moving forward through the container or backward through the container, and whether we want to treat the object that the iterator is, quote, pointing to, unquote, as a variable or as a const. Okay, so we can get iterators for containers using some form of begin or end, or r_begin or r_end, or what have you. And we know that we can access the object that an iterator is currently, quote, pointing to, unquote, by doing star on the iterator. We know that we can move the iterator along to the next item by doing plus plus on the iterator. And we know that we can test whether an iterator is not equal to some other iterator, specifically not equal to end, by using exclamation mark equal. But now let's take a look at various other things that we can do to interact with and manipulate iterators as well. It turns out that iterators fall into three categories. There are what are called forward iterators that allow you to step through the elements of a container in one direction, whatever the natural direction is, for whether you use begin for an iterator or r_begin for a reverse iterator. There are also what are called bi-directional iterators, which allow you to go the opposite way of a forward iterator. So if you have a bi-directional iterator, you can go both forward and backward through the container. A random access iterator is able to go both forward through the container and backward through the container, and also do things like using subscripting to access a particular element somewhere in the midst of the container. Now, I want to be clear that these are categories, not data types. A forward iterator is an iterator that provides certain operations that allow you to move the iterator forward through the container. A bidirectional iterator allows you to not only move forward through the container, but also to move backward through the container. And a random access iterator is an iterator that allows you not only to move forward and backward, but also allows you to access arbitrary elements using subscripts. You can also do things like comparing whether one random access iterator is less than another one, and so on. So specifically, an iterator is a forward iterator if it supports all of these operations. That is, it needs to be able to support star to access the element of the container that the iterator is currently pointing to. It also needs to support the arrow notation in case the iterator is pointing to a class or a struct that has member functions or data members. It needs to support the plus plus operation, which will move the iterator forward to the next element in the container. And not only must it support the pre-increment, but it must also support the post-increment. Now, the post-increment, it turns out, is less efficient than the pre-increment, and so the post-increment is very seldom used. A forward iterator also needs to support equality testing, also inequality testing, and assignment of an iterator to another iterator of the same type.